Hi everyone, here's a video where I will work out all of the problems on the study guide to review for our quadrilaterals test. These always, sometimes, or never statements are really tricky. We want to go carefully through these, drawing pictures and thinking about it. We can't reason based on appearances, but we can draw pictures to help us to just think about the symmetry that the shapes have or the transformations that the shapes would have. Okay, so going through these, for the first one, diagonals of parallelograms are congruent. Okay, so first of all, understanding that rhombuses, rectangles, and squares are all parallelograms. So diagonals of a parallelogram are congruent. So in this particular picture of a parallelogram up here, the diagonals are not congruent because we have this diagonal here compared to this diagonal, this shorter diagonal here. So because it does not have reflectional symmetry, these diagonals are not congruent. But if we look at the rectangle, the diagonals would have to be congruent because it would have reflectional line symmetry across that horizontal. Okay, so that means that it's sometimes congruent, but not always. The next one says, parallelograms are rectangles. Is that always true? Is it sometimes true, or is it never true? Well, in our family tree, we have that the parallelograms are above the rhombuses and the rectangles. So that means that all rectangles are parallelograms, but not all parallelograms are rectangles. So this would be sometimes true because the rectangle is a parallelogram, but the parallelogram is not a rectangle necessarily. Okay, part C, diagonals of a rhombus are perpendicular. Okay, so here the diagonals of the rhombus would always be perpendicular because they would have that symmetry. So that one is true, always. Next one, consecutive sides of a rectangle are congruent. Okay, so consecutive sides, that would be like this side and this side. So here in this one, we see that consecutive sides are not congruent necessarily, but for a square, which is a rectangle, they would be. So again, that is sometimes true. Diagonals of a trapezoid are congruent. Okay, so this particular trapezoid is not isosceles, so it doesn't have reflectional symmetry vertically, which means that here the diagonals would not be congruent, but if it was isosceles, they would be. So again, this one is also sometimes true. Consecutive angles of a parallelogram are congruent. So consecutive angles, that would be like this acute angle here and this obtuse angle here. So in this example, consecutive angles are not congruent, but in the rectangle, which is a parallelogram, they are. So again, this one is also sometimes true. Next question, number 2, to prove segments are congruent, the distance formula is used. The distance formula, which is basically the same thing as the Pythagorean theorem. So sometimes when we were doing our coordinate proofs, we would draw in right triangles and use the Pythagorean theorem to find those distances to show that the segments are congruent. Okay, to prove segments are parallel, we would use the slope formula, that we would need the same slope. To prove segments are perpendicular, we would use the slope formula. Those slopes would have to be opposite reciprocals. To prove segments bisect each other, we use the midpoint formula. Use the midpoint formula in order to show that the point of intersection is also the middle point, which splits each of the segments into two equal parts. For number 6, given square ABCD with diagonals AC and BD that intersect at E, the measure of angle CED. In order to figure out this problem here, we do have to draw a picture. So here's a picture of square ABCD with diagonals AC and BD that intersected E. The measure of angle CED, so angle C to E to D. Well, the diagonals have to be perpendicular, so angle CED has to be 90 degrees. Given square ABCD with diagonals AC and BD that intersected E, so it's the same drawing, the measure of side ED, the measure from E to D, that's the length from here to here. So we know that any one of these other sections here have to be equal. So looking for a section where that's equal, AE would be one of those sections. BD would be the full diagonal, so it's not that. AB would be a side of the square, so it's not that. And CD would also be a side of the square, so it's not that. So the answer is A. Given square ABCD with diagonals AC and BD that intersected E, the measure of angle CED. So that's the same question we had before, and that answer is C, 90 degrees. Number 8, find the length from A to M in the parallelogram if the length from P to N is 9. So marking that up, the length from P to N is 9. And A to O is 4. So if A to O is 4, then the distance from A to M must be the same as that. So that distance must also be 4. In this coordinate proof, I graph all 4 points A, B, C, and D, and then I'm going to determine and prove what type of quadrilateral this is. Okay, so my conjecture looking at those 4 points is that it's a square. So if it's a square, then it would have to have 4 congruent sides and 4 congruent angles. So to prove that it has 4 congruent sides, I would draw in triangles and do the Pythagorean theorem to get my supporting evidence. And to get 4 congruent angles, I'd have to find the slopes and show that those slopes are opposite reciprocals. So to prove a square, that means that I do not need to prove that it is not anything. So for instance, a square is the bottom, is the very most specific quadrilateral. It's the bottom of the food chain, so there's absolutely nothing else that it could also be. Okay, so based on this, let's go about proving this. I also do not have to prove that the opposite sides are parallel, because if it's a square, then it's also a parallelogram. So I don't have to bother to prove that it's also a parallelogram. Let's first then show that all 4 of these sides are congruent. Okay, so in these triangles, it looks like I have 1, 2, 3, 4, 5, 6 by 1, 2, 3, 4, 5, 6, 7, 8. So 6 by 8. So figuring out the side AB, we have 6 squared plus 8 squared is C squared. So that's 36 plus 64, which is 100. So 100 is equal to C squared. So when I square root that, I end up getting 10. That means that this side here is 10. Counting the other side, it's 1, 2, 3, 4, 5, 6 by 1, 2, 3, 4, 5, 6, 7, 8. So it's also 6 by 8. That means that its diagonal length is also 10. That I don't have to redo the Pythagorean theorem, because I just did that calculation. Finding the other sides, I have 1, 2, 3, 4, 5, 6 by 1, 2, 3, 4, 5, 6, 7, 8. So this one is also 6 by 8. So that shows that this is also 10. The last side is 1, 2, 3, 4, 5, 6, 7, 8 by 2, 3, 4, 5, 6. So it's also 8 by 6, which means that last diagonal length is also 10. So therefore, I have the supporting evidence that all of those sides are equal. Writing that up in my coordinate proof, I can write that side, the distance from A to B is equal to the distance from B to C, which is equal to the distance from C to D, which is equal to the distance from D to A, which is equal to 10. So all those distances are 10. And the supporting evidence, I did that calculation that all of these have a length of 10. So that move right there shows that this has to, that this quadrilateral must be a rhombus. Remembering that a square is both a rhombus and a rectangle. So the next step is to show that all of the angles are the same. Okay, so that means that I have to show right here that that all the angles are 90 degrees, that the slopes are opposite reciprocals. Because if the slopes are opposite reciprocals, then the segments are perpendicular, which means that that we have 90 degrees. Okay, so next I want to calculate out the slopes. So the slope of side AB rises 6 and runs 8. So that's a slope of 6 over 8, which is 3 over 4. So that first slope is 3 over 4. Then the next slope rises down 8 and over 6. So that's 8 over 6, which is 4 over 3. And it's also going downhill, so that slope is negative 4 over 3. Negative 4 over 3. And I notice that those are opposite reciprocals, so I can put in my right angle right there. I can mark, I know that that's a right angle because my slopes are opposite reciprocals. So finding my next side slope, I am going 6 and 8, and it's going uphill, so that slope here is 3/4. 3/4. So 3/4 and negative 4/3, so this must be a right angle there. Okay, then the last slope is we are going down 8 and right 6. That slope is going downhill left to right, so that slope is negative 4/3. Negative 4/3. So negative 4/3 and 3/4 shows that these two segments, segment AD and DC, are perpendicular. And then I also have that negative 4/3 here and 3/4, so that must also be a right angle. Okay, so writing that up in my coordinate proof. So now I will say segment AB, so it needs the segment hat, is perpendicular to segment BC. I could say segment BC is perpendicular to segment CD. Segment CD is perpendicular to segment DA. And segment DA is perpendicular to segment AB. And I know that all because for each of them, one slope is 3/4 and one slope is negative 4 over 3. So that supporting evidence would be for all of those. Right? So based on this, I know that it's also a rectangle, that it has 4 right angles. So because I've proven that it's both a rectangle and a rhombus, therefore I've proven that quadrilateral ABCD is a square. So therefore ABCD is a square because I've proven that it's both a rhombus having 4 congruent sides and a rectangle having 4 congruent angles. In this coordinate proof, we're trying to determine and prove what type of triangle this is using angles obtuse, right, and acute, and sides isosceles, scalene, and equilateral. So going through this one. So here's a game plan for figuring out this problem. Let's first find the length of all three of the sides of that triangle, because if we figure out those lengths, then we could do it like the problems we had from the last unit, where we could use c squared equals a squared plus b squared to tell if the triangle is acute, right, or obtuse. So for instance, if that c squared of that hypotenuse fits just right, then it's a right triangle, but if that c squared is too small, it must be acute. If c squared is too large, it must be obtuse. We could also use these three sides to figure out, is it no equal sides where it's scalene? Is it two equal sides where it's isosceles? Or is it three equal sides where it's equilateral? So then we could classify it according to obtuse, right, and acute, and also if it's isosceles, scalene, or equilateral. So going through this problem, first step is to find the length of all three sides. So the length of xy, well, we could just count that. That's 1, 2, 3, 4, 5. So the length of xy is 5. To figure out the length of xz, that's in a diagonal, so that right triangle is 2 by 1, 2, 3, 4. 2 by 4. So doing Pythagorean theorem on that, that's 4 squared plus 2 squared. Is c squared. So that'll be 16 plus 4, which is 20. So square root of 20 is that distance. I'm just going to write that distance in as square root of 20. And then this last distance, that triangle, is 2 by 1. So doing Pythagorean theorem on that, that's 2 squared plus 1 squared is c squared. So we'll have 4 plus 1 is c squared. So 5 is c squared. So c is square root of 5. So the lengths of the sides are 5 square root of 20 and square root of 5. Okay, so now this problem looks more like the ones that we've done before. So using c squared equals a squared plus b squared to classify this triangle. Okay, so 5 squared is 25, and that'll be square root of 20 squared, which is 20, plus square root of 5 squared, which is 5. So 25 equals 25, so it fits perfectly. That means that this is surprisingly a right triangle. So it's a right triangle. Also, we have that all three distances are different numbers. So square root of 20 is like 4.2 something, and square root of 5 is like 2.23. So having all different sides, that means that this must also be a scalene triangle. And we've figured out what type of a triangle this is. In this problem, we're trying to figure out our points A, B, C, and D. Is this quadrilateral a kite or a rhombus? So one way to do it is to draw in these right triangles, and we'll find and see if all four segments are the same lengths or if they're different lengths. So the length of segment AB is 3 by 5. So calculating that out, that's 3 squared plus 5 squared, which is 9 plus 25. So together that's 34, which is c squared. So square rooting that, the length of AB is square root of 34. The next triangle is 1, 2, 3, 4, 5, 6 by 1, 2, 3, so 6 by 3. So I'm starting to think that this is a kite rather than a rhombus. If I calculate out that distance, I'll have 6 squared plus 3 squared is c squared, so that's 36 plus 9, which is 45 square rooted. So that distance here is 45. So I see that they're not equal, which means that this is not a rhombus. CD is 3 by 6 also, so that's also square root of 45. And AD is 3 by 5, so that's also square root of 34. So I see that these two segments are congruent, and these two segments are congruent, making this basically a kite, because it has two pairs of consecutive congruent sides. In this problem, we have to draw and label all three vertices for a right triangle with leg lengths of B and C. So one way to do this is to have vertices here. So this point right there that has a length of B, which means that that's on the x-axis, so it's B. So this point here has coordinates of B0. If this length is to be C, then this point right there has to have coordinates 0C. So, for instance, if C was equal to 4, then it would be at coordinates 0, 4. If B were equal to 3, then it would have coordinates of 3, 0. That other point, then, we would also have to label as at 0, 0. So now we have a right triangle. For this one, we want an isosceles triangle with a base length of 8p. Okay, so that p could be like a proportion factor. So one way to do this is to have 1 point. So if this is 0.00, we could go negative 4p0 in one direction, and we could go 4p0 in the other direction. And then it would have a total length there of 8p for our base. Then this point here could just be up some random value. That would have to be on the y-axis. So it would have to have coordinates 0 and then any other variable. So now we'd have an isosceles triangle with a base length of 8p. The numbering on this packet is not correct, but we have two separate problems, number 14 and number 23. Okay, so for this 14, we want to find the slope, length, and midpoint of the following segment. Okay, so to do this, we could plot out these points. So we're at 2, negative 4. Here's the point 2, negative 4. And the point 3, 2. So coordinates 3, 2. That's y. So we're looking for the slope, the mid-length, and the midpoint of that segment. Drawing in a right triangle, that right triangle has a length of 1 and a height of 6. So that means that its slope is rise over run. So its slope must equal 6 divided by 1, which is 6. And it's positive 6 because it's going uphill. Then its distance, we could do the Pythagorean theorem and get 6 squared plus 1 squared is c squared. So that'll be 36 plus 1, so 37. Then when we square root that, that's our distance. So our distance is square root of 37. And the midpoint, so the average for the x-coordinates is going to be 3 plus 2 divided by 2. So that's 2.5. And the y value is the average of 2 and negative 4. So 2 plus negative 4 divided by 2, and we get negative 1. So the midpoint is at 2.5 and negative 1. For this problem, we have different points. We have points negative 2, 4, and 3, negative 2. Okay, so we could calculate out the slope and the distance by drawing in a right triangle here. So in that right triangle, looks like we're going to go a distance of 6 in the rise and a run distance of 5. So that means that its slope must be rising 6, running 5, but it's negative because it's going downhill. Looking more carefully at this, I see there's an inconsistency because this point here should be over 1 to line up with, to be at negative 2, 4. So that's what it should be. So that way we would be going down 6 and right 5. Okay? Finding the distance, you will do Pythagorean theorem with 6 and 5. So 6 squared plus 5 squared is c squared. So we'll have 36 plus 25, which is going to equal 61. So square rooting that, we get our distance. Square root of 61. And for the midpoint, I can average the x values. So the average x value is going to be negative 2 plus 3 divided by two numbers, which is 1/2. The y value will be at the average of 4 and negative 2, so 4 plus negative 2. And that's divided by 2. 1. So that equals 1. So the midpoint is at coordinates of 1/2 and 1. Each of these edges has been reinforced with a piece of tape, so I can mark up this diagram. I have that the height here is 10. I have that this side here is 10. And then the very back side that we can't see is also 10. That would be that back part. The sections which are 20 would be this section right here, this section right here, this section right here, and the back section would also be 20. So we have 4 of the 20s. We could figure out that we're also going to have 4 of the 12s. That those would be the distances that are here, 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 and in the back here. So altogether in this problem we'll have 4 of the 10s and 4 of the 12s and 4 of the 20s. So multiplying that out, I'll have a length of 40 plus 48 plus 80. So that turns out to be 168 inches of tape. This last question turns out to be an incomplete question, so we are done. We end up getting 1.